Hello folks, this is the video segment for chapter 2 of my textbook, and the title of the chapter is laminated plate under tension using the manual ply creation. Let me quickly tell you what this is about. So we have a plate which is consisting of 4 plies, a laminated composite consisting of 4 plies that you see here, 45 minus 45 minus 45 and 45. And this plate is being pulled on both sides with a distributed force of 1,000 pounds per inch. Okay. Now, the length of this I'm going to assume is 4 inches. The width is 1 inch. Excuse me. And uh, the 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 laminate is symmetrically placed about that reference plate that you see here. So uh, the thickness of each ply being 0.05 inch, 2 on top, which makes it 0.1, and 2 in the bottom, makes it another 0.1. So total laminate thickness here is uh, point 0.2. Okay. Now the material properties of the laminate are given here. I'm taking it out of this lecture notes from somewhere in East Carolina, and the strength properties are also given on the side. Okay. Now, if you look at the problem, that we have, we are pulling it on both sides and there's no restraints on it. So of course, in this particular problem, there are 2 planes of symmetry that one can use. However, I'm not using that, and therefore I'm modeling the whole thing. And because of that, I have to prevent the rigid body motion of this, and I use the 1, 2, 3 rule. The details are in the textbook. Please consult them. So I will retrace my steps exactly like it's done in the book. And all right, so let's get this thing going. The first thing I did, I went to the compass on the top left corner, and I scrolled down and I got material definition, which is one of my favorite application. I mean, if you don't have it here, you have to scroll further down and find material application. Okay, but I already did that because I didn't want to waste time on connecting through internet. So there it is. Okay. Now I'm gonna create the materials first, okay? So the materials, one way of doing it, this is not the best way, this is not the only way. Here, when you go to that material definition, immediately it creates a core material for you. But this is a placeholder, there's nothing in it yet. It's just a dummy material that is created. And you can rename these things to be different things. For example, right-click properties, I'm gonna call it in case I want to track it down later on, video wait a minute, video chapter 2. Okay. Composites. All right, and say apply. Notice that this name changes right away. I'm going to close that. Now put the cursor there, and you can say either you double click on it. You see that you double that's not what I meant. uh, uh, you place the cursor there, right click, and you say add domain. That's one way of doing it. Or that's what this thing is. It says add domain. See that? Add domain, or you put the cursor there, right click, add domain. Either way. So I'm going to use this add domain, and it says, well, what is it that I want to add? Well, first I want to add the composites. Okay. And you cannot do that simultaneously. I want to do composites and simulation, but I don't believe you can do that together. So I'm going to say, okay, composites, say fine. And notice that what happens, it adds a composite branch here, okay? And if you want, you can, well, let me add the other one too. So put the cursor, click on this again, add domain on this, and this time simulation. Same name. Okay, so I have these two. Now I have to fill in the data. If I double click on this, thing, the table associated with that particular composite opens up. The only thing that I need to change here is the cured thickness, which I said is 0.05. Okay, 0.05. Now, these things, although they are important, but for the purpose of this chapter that we're using, uh, they're not relevant. Okay. Now, the other thing is that here it allows you to define the type of the composite that you're trying to use. Mine is unidirectional, that's the intention. But changing this from bidirectional to unidirectional to something else will have absolutely no bearing on my problem today. Okay? It affects your bill of material. If you're trying to get a bill of material, it tells you that it's unidirectional or bidirectional. The only thing that's important for me is that cured thickness. Okay, you say okay. Now, as far as the material data is concerned, in other words, this information is concerned. Okay, so what I do is I double click on this simulation. I go to structural, Abacus multiphysics. I'm not going to specify density because it's not relevant in this problem, but I go to mechanical, go to elasticity and elastic. Now here, you choose the type of material that you want. I want lamina. Okay, so you click on the lamina and notice what happens. Immediately, you get boxes for the numbers that you have in that table. So this first one was 20 million psi, 20 e to the 6. This one, this is a transverse Young's modulus, was 1.2 e to the 6. Poisson ratio was 0.25. G1 was 800,000. G12 was 800,000 psi. This one, now this one I think I'm taking it as half of that. Okay, and same thing with down G23. G23 400,000. I took it half because in the problem that we're doing, these particular two are not very important, and I didn't find it in that set of lecture notes, so I just took half of this value. Okay. Now the other thing is that if you want to input the strength properties, see that strength properties, you have to go to further scroll down, and you go to, you see now, where is this thing? You go to damage and fiber reinforced composites, and just click on it. Well, actually, I'm using the say check on this. Okay, and you can put in the numbers that you want. Okay, so this one, let me see, it was 300,000. 300,000. 1, 2, 3, 4, 5. This one, the compressive longitudinal compressive strength is 150,000. However, in this software, if you put a positive 150,000, it will run, but it will come back and give you a warning that this number should have been negative. In some other software, if you put negative, actually it won't run. Okay, so here I'm going to put minus 150,000, 150,000. Okay, and transverse, let me see now, what are the transverse values? There is 7,000 and minus 25,000. So this is 7,000, 1, 2, 3, 4, minus 24, 5,000, minus 25,000. And shear for longitude, for the shear strength is 14,000. This last one, I don't have it, so we just ignore this. And let me say, okay. One error to edit, so let me see what the error is. Let's see if we can find out that this could cause a material. What is the error? So let me see what the error may be. longitudinal compressive must be greater than 0. Okay, so longitudinal compressive strength in fiber direction must be greater than 0. Okay, so what I'm going to do is double click on this. Sorry, double click on this. I will change this thing. I will change this thing to fail stress. Okay, and now I'm pretty sure what I told you is going to work. So apparently in hashing damage, you need to put a positive value. So let's try it. 300,000, 1, 2, 3, minus 150, minus 150, 1, 2, 3. This was 7,000, and this was minus 25,000, 3, and this one was 14. Yeah, and these last two, I don't have data for it. We just leave it the way it is. See, 14,000, right? And then we say, okay, I should not be getting an error message, right? The other one I used hashing, but even in the book, I'm not using hashing. I use the stress criteria, and therefore there was no issue there. Okay, all right. So I'm going to save this. So we inputted the material data first. Now, in the book, I'm saying that you don't have to do that now. You can actually go and create your geometry and then input your material data later on. And I stand by it. However, to be consistent with what's in the book, I did it now. Now we're going to go and create a model. So we go to the compass and generative shape design. Okay, and this is simply a surface. This is why I can do it in generative shape design. There's no problem. So you select the XY plane and you sketch on it a rectangle that's 1 inch by 4 inches. So there, it's the wrong thing. Rosette. What I meant is the rectangle right there, and dimension it. This is 4 inches, and the width is 1 inch. And we exit. You have to put a surface on this, so I go to the surface tab right there, and there's a fill here, and we say okay. Notice that you could have, if you want, you could have drawn a line and extruded it, but this is the way I've done it in the book, and I'll do it like that. Now, we need a rosette too. So this rosette is basically an access system that you can place it anywhere, and you place your plies using the x-axis as reference orientation. But it can be anywhere. So if you look at the essentials here, there is the access system there. Automatically, if you don't specify its origin or orientation, it puts it at the global origin right there and aligned with the XYZ. So this is fine with me. It's just that I would have preferred if this was off the off the surface, and in that case, I should go and right click, create a point, and then it moves my origin. But this is fine for me. I'm just going to uncheck this current. Okay, that's all. That means do not use that coordinate system, although it doesn't matter because it's aligned with my global system and it's centered at the global origin. But I'm saying don't use that. Use the global XYZ as any XYZ that I input. Okay, good. Now, pretty much it. This is my part. I have nothing else to do. So, okay. Um, so let's go ahead to our composite design. There's the composite design workbench. There we are. Okay, notice that the action path changed all down here. Okay, so the first thing that we're going to do, we have to create a composite parameter. So there is the composite parameters. You click on it. Okay, it says, well, you want to add a material. I'll say yes. From the database, you click on it, and notice that because this material tab is still there, that stuff that I created at the beginning is sitting right there, okay? I can bring this thing in the front and then select it, okay? If this was not here, then what you can do is you can go there and say, show me all my material database, for example. And if I already have created something and I saved it, it's going to be material database. Here, I don't have to do that because it's sitting right there. So all I do is I click on this tab, and there we are. See that? And I go and select this. Basically, I selected my material. That's it. And as soon as you do that, it goes back here and it populates this data. Okay. Now remember, the only thing that I changed was this Q thickness, which is 0.05, and I also changed the material directionality, unidirectional. However, as I said, this is not relevant. So click on the rosette. There is no rosette here. You say add a rosette. So I go and select what I created, either from here or from the tree. This is my rosette. And if it's bothering me, I can always hide it. And this number actually controls the size of the rosette. So I can make it bigger. Notice that it says 1 inch here. For example, if I made this thing 0.5, it's going to become smaller. Sometimes this may not be very convenient. You see that? We say, okay, fine. Nothing else that I need to do here. The only thing that I need is the orientation, but 45 and minus 45 are among the default orientation. If you have an orientation which is not listed here, you click on it, add direction, and you add plus 30 or minus 30, whatever. I'm done. Okay, so this takes care of the composite parameters. Okay, so I'm going to do this thing by the so-called manual ply method because it's very simple. Okay, but if you have a part that has many different types of laminates, different orientation, different even materials, then doing it manually may not be a good idea. So it's very cumbersome. So it says Plies group. You click on it. It says the surface. The default name is ply group 1. Surface is that surface, and it gives you a draping direction. So I'm going to drape it in the vertical direction upward. Okay. If this is not convenient for you, you can flip it down, whatever. But this is good, and lock the plies draping direction to go with this ply group, which is fine. Okay. Now the next thing is, notice that the plies group has been created. Now that we have a ply group, we're going to create our ply. Right there, create supply manually. When you click on this thing, and you see, you click on this, nothing happens. Okay, and you wonder what's going on. That's because it's expecting you to go and select the group where you want to put this ply in. And I want to put it in plies group 1. Okay, now it opens up. Now, what is the boundary of this ply? Obviously, the ply is covering that entire thing, and the best way is to go and select the sketch. Now, see, it picked this thing. Sometimes you may want to get the actual boundary instead of the sketch, actual boundary of the surface, but in my case, it doesn't matter. You select the attributes tab. Notice the material was correctly picked, okay? And the angle, however, the first one, my first ply is 45 degrees, okay? So the angle is not correct here. I'm going to change this thing to 45. Rosette is correctly picked. Say okay, and there is my first ply. There's my first ply, and repeat this thing 4 times. But I'm going to do it twice, and then I use the mirror feature in order to reflect it with respect to that plane. So another ply, once again in that ply group. Once again, the boundary is that sketch 1, and the angle is minus 45. And I can do this thing 2 more times, true, but I'm not going to do it like that. There is an icon here which says symmetric plies stacking. You click on it. It says, what is the plies group? Okay, this is the thing that I want to make symmetric, right there. And non-pivot means that 2 up and 2 below, okay? If I say pivot, means that 45 on top, minus 45 in the middle, and 45 at the bottom. So there's going to be 3 plies if I do pivot, okay? But no, I want to do 2 up and two down. Okay, so I say non-pivot. We say okay. Notice that it did create the 4 plies for me. Now, how do I check this thing? If you go to review, here, there is something called the ply exploder. Right. Let me move this thing here. Ply exploder right there. I have 1 ply group. Okay, and I want to see how they look. So I selected that and I say apply. Notice that it gives you 45, minus 45, minus 45, 45. Probably we didn't pay attention to these colors, but for example, 45 was associated with red and minus 45 with green. Okay, so that's good. Now we can hide this thing or we can cancel it. It really doesn't matter. I don't need it anymore, so I'm going to cancel it. Okay, good. So this takes care of my composite design workbench. So let me save this thing. All right. Now we're going to go to uh, structure model creation. You click on it. Now, don't change any of these. Okay, so we say okay. If you had a part here, if you had a part three-dimensional part here, it would go and automatically mesh it for you. But I don't have a three-dimensional part, so everything I have to do myself. Okay, so notice that the finite element model has been created. There are nodes in it and their properties, but they're all blank. There's nothing in these. So I can create the properties first, or I can do the nodes and elements first. In the book, I've done nodes and elements first, which is obviously not here. If I wanted to do the properties first, I have it right there. See that? It says here composite cell section, but to be consistent, just like in the book, so I go and change to measure. Okay, and there is your surface quad measure right there. You can see that. I select surface, and I'm going to put the thickness of the size 0.125, because this was 1 inch. If I put the size 0.125 here, there's going to be 8 this way, and I don't know, 20, 8 this way, and 4 divided by that, 16 in the oh no, 32 in this direction, in the length direction. This is okay. And don't worry about any of these other things. I'm using parabolic, so 8-noded, the 8-noded uh, quad element, okay? And we don't worry about it. If I say mesh, just shows you the mesh here, you say okay. All right, good. Now, if you don't want to see the mesh, the elements has been created here. If you don't want to see this mesh, either you can hide it from here, you can say hide and show, okay? Let me put it back. Or you can right click visualization management, and under the finite element, I want to say hide. These are little things that probably you're familiar with if you have used 3D Experience FEA before. Check my other book on Essentials of Finite Element Analysis in 3D Experience. All right, good. Now we're going to do the properties. Now the properties, you cannot do it while you're in the measure. This is the measure. So you go back to model right there. See that? Put the cursor there, back to model, and you end up with where you were before. Now, on the properties, we have here uh, different type of properties. For example, if you had a continuum shell elements, etc., then I have to use the right one. But here I have the standard general shell elements, so composite shell section. Okay, you click on it. It says, what is the support? Well, the support is the different ways of doing it. What I suggest, and I said in the book, you go and select the surface mesh quad mesh one here. Okay. There are other ways of doing it too. And for the composite cell section, well, I can select it by different ways. But what I'm going to do in the book, I said that let's do it by the ply. So it says, well, which ply, which group? I mean, there's only one group here. So I select that and notice that it did pick it. Very important. You see that you go to the advanced, and here it says offsets definition. Now notice that the different choices here. For example, if I say none, it's going to place it symmetrically above and below that surface. There's no offset. If I say, for example, bottom surface, what it's going to do, the bottom surface is going to sit on this. bottom surface of the ply, and the ply 1 is going to sit here. But I want to say, excuse me, none. Say okay. Very good. Notice that this has been created here. Shell section, composite shell section has been created. I'm going to save everything. Okay. Now we're going to go to the structural scenario creation. It's a structural problem that we're doing. So we say okay. All right. Now, notice that what happens is that immediately you get this thing in the bottom, or I mean, default position is in the middle. I've moved it away so I can see it, uh, with exclamation marks here. That's because these are both missing. So what we're going to do is we're going to go under the setup. You select your finite element model. There's only one here. You select it. And you say, OK. And this exclamation mark goes away. The reason is that you may have several different meshes and you may want to use a particular one for this analysis. So it says which one do you want to use, and in my case there's only one, but I still had to do it, otherwise this red exclamation mark would have been. Now, the procedure, it says, well, what kind of analysis do you want to do? Static, quasi-static, etc., etc. Well, I want to do static. You click on it, notice that immediately this red exclamation mark turned into green check mark. Okay, this is a linear problem, linear analysis problem. Okay, and therefore it's going to happen in one step. It's not iterative. However, do not include the nonlinear geometric effect. Under advanced, you click on it. Do not include geometric nonlinearity. So uncheck that, and then you say okay. That's pretty much it. All right, this guy is bothering me, so let me hide that. Right click, hide. Okay, very good. Okay, I don't need the rosette. I can hide it. Okay, I don't need this access system. Anything that I don't need, I can hide. Okay, hide, hide, and hide. Okay, very good. Now we need the loads. Okay, let's do the loads. If you look at the force, you want the shell edge load. Shell edge load. You click on it. So I want to put 1,000 pound per inch this way, 1,000 pound per inch this way. So ordinarily you can go and select this, but the problem is that it won't let you pick it. The reason it won't let you pick it is that there are two things sitting on top of that: the ply boundaries and the sketch. So the ply boundaries, it's very easy. You can go there and just say hide it. Notice that it did hide it. That red stuff on the boundary is all gone. But I still cannot pick it because that sketch is also sitting there, which is blocking my view right there. So hide this. And now I can go and pick. Okay. First of all, if you put a positive number here, by default, it's like pressure. If you put a positive edge load, it's going to compress this. So I want minus 1,000. And I want this edge, but just to convince you, see, it flipped it so that it puts it in tension. You can see that. And I want the other edge. And if you look at it, because the value is still negative, it's tensile on both sides. And we say, okay, this is done. The next thing I want to do is apply restraints. And at this corner, I want to, fix all three movements. So you select it. You have to go and select that corner point. Now, you may have a hard time picking it because these forces are blocking. So let me hide the forces. Now I can select this corner. Okay. All right, so I want all three translations to be fixed there. I repeat this thing, this corner point, no displacement in X, no displacement in Z, but we allow it to shrink this way, Poisson ratio effect. And finally, over here, no displacement in direction Z. This is called the 1, 2, 3 rule. It's very common in finite elements. Okay. There is an automatic way of taking care of 1, 2, 3 rule, which is called inertia relief, but I don't want to discuss it in this particular video, and I did not do that in the book either, this chapter at least. That's pretty much it. So now, if you go to the simulation, look, I'm assuming that people have some familiarity with doing FEA on 3D experience. If not, please get hold of my other book, which has nothing to do with composites, but it tells you how to do FEA in 3D experience. Okay. The release 2017 was published, and 2021, which is what we're using now, is should be out in a few weeks. Okay. And when I say a few weeks, right now, it's March. Uh, it's March 12th, 2021. Okay. All right. So the first thing that we're going to do is, before I actually run this thing, and because I'm dealing with a laminated composite, I want to be able to see the stresses in different layers or plies. Ordinarily, that is not given to you, so you have to go ask for it. This is how you ask for additional output. You click on it. It says, well, what do you want? First of all, do you want it for the whole model? The answer is not really. I want it for my, for example, meshed part. Okay, meshed part right there, meshed part. And the mesh part is just this single mesh that I picked. And then is it every increment? This is a linear problem, so increment does not have any really meaning in this case, so just don't worry about it. And I want to get the stresses. And when you say a stress, it gives you a whole whack of things, but all I want is really the stress component. And if you want to plot some of the failure criteria, such as Saibu, Sahil, etc., then you have to go ask for it. This is failure measure. See this? Question is, which one do you want to pick? In the book, I just checked these three or these four. However, yeah, I mean, basically, this is the Sahil, Saiwu, maximum strain failure, and maximum stress theory. These are common ones which are discussed in basic books. Okay. And now the question is, where do you want it? Well, I want it, well, first of all, I want it at every layer, by layer, okay? You can ask for it by section point. Remember, each shell element has 3 integration points through the thickness, or you can say by layer, on top, bottom, and middle, depending on what you want to look at later on. And that's pretty much it. And you say, okay. If you want to do it by section point, then you have to specify, well, you get a secondary table here, you have to say which section point, but this is fine. All right, good. So let's click on the model scenario check. It's a good idea to do these, because sometimes with the trivial mistakes, they're going to pop up here. Okay, so yeah, no mistake, at least for this checker. Then I'm going to do the simulation check. Say okay. I have only my basic computer with 4 cores. Any warnings and errors are going to appear here. As long as they're warning, it's a good idea to proceed with simulation. But if there are errors, in all likelihood, it's not going to go past that. You have to check what the error is and fix it. Okay. Done. and finally simulation. Say okay. Now here you can display some information. If you're doing a problem which is nonlinear, it's going to do iterations there. It's going to, for our case, it's a simple step. It's going to do one. We can also plot the plot and see the progression of the calculation through time. Okay, like that. Your iteration. There's only one iteration, and it's going to finish. Okay, close it. Now, zero stress. One misses, zero stress. Okay. The problem is that, well, zero stress means that this is the first step when no load was applied. In this case, you have to look at 2, which is not 0 anymore. You can see that's 62, almost 6200 psi. But this is not very informative. It doesn't tell me where, okay? Uh, so what I'm just going to suggest, first of all, let's look at the deflection, displacement. Aha, that's better. Notice that what happens, if you look at this thing from the top, view from the top, let me see for a second, view from the top view. So what happens is that you had a uh, strip of composite material and you pulled it on both sides. Because this stacking sequence is symmetric, and is because it's balanced, okay, and in this case symmetry is not that uh, yeah, because it's symmetry, you place the load at the middle surface, and yeah, and because it's symmetric, it only stretches. There's no shearing effect. These are basic things that they teach you in a composite course. So laminate, which is symmetric and balanced, when you apply it transversely, it's just going to stretch like a piece of metal, for example. Yeah. So the amount of displacement is given here. And so this is fine, but I want to look at the stresses. Okay, I want to look at the stresses ply by ply. So I go there, I go to the plots tab, okay, and I'm already there, no problem. You click on the contour plot, and then here you have to select whatever you want to do. Look, I want to see stress components, okay, and I don't want to see overall. I want to see specific ply. For example, ply number 4. And I want to see it at the middle of the ply number 4. Remember, plies are sheets, okay? These sheets have the top surface and the bottom surface and the middle surface, okay? So I want to look at the middle surface, think about it like that. And well, here you can look at the one misses, or you can look at other components, You can look at the one misses, or you can look at other components and a whole whack of other things that you can look at. For example, if I look at the shear, it's right there, tensor component, 1, 2 is the shear, and then move this thing on the side, let me move it here, and then say apply. Nothing exciting is going to happen, because this particular problem, because of the nature of the stacking sequence and the loading, everything is going to be constant. So this is the shear stress in lamina number 4 at the middle section. In fact, it's constant. Don't expect to get same color in other problems. If this was bending, of course, the colors will be different. And in the other in the other chapters, you will do more complicated problems. And when I say complicated, it's not that the steps are identical. It's just that, we look at different type of loading, different kind of sequences, etc. Now, the other thing is that if you want to look at, for example, Saivu failure, you can do it from here. See that Saivu or Sahil, whatever. You can either do it from here, or let me close this thing for a second. You can also go back there and look at the I guess right here. Well, I guess for failure you have no choice. You could have seen the different components of stress in this from this one, but let's go back there. Try it again. Uh, I want psi wu, okay, a particular layer, for example, layer number 2, and we look at the middle surface, and then we say apply, and you get 0.192. I want to remind you, as long as this number is less than 1, according to that failure criteria, it is safe, it's not failing. When it reaches 1, and in this particular problem, because of the nature of, as I said, the fact that the stresses are all constant in different layers, this doesn't change if you go to other layers. For example, if you go number 4, nothing changes. In general, these numbers will change. One last thing that I want to do today is to show you something that's very useful. If you go and click on this, let me put this thing in the isometric view, but it doesn't have to be. Ply stack plot, ply stack plot. You click on it, nothing is there. But if you click on that, it shows you the layout. So remember, there was 45 minus 45. See, here's the x-axis, 45 minus 45 minus 45 and 45. But the more important, the more interesting thing is that down here there is a matrix. If you click on it, it gives you the same thing, but it gives you the so-called ABD matrices that are bread and butter of the classical laminate theory. All these finite element matrices use ABD. All these finite element codes use these matrices. This is A, this is B, and this is D to do the calculations. Okay, because the laminate is symmetric, the B is 0. But there we are. All right, folks. So good luck. Second one will be the next video segment for chapter 3 will be available soon.